So far we've done a few applications of integrals. Most recently we did the area between two curves. Now we're going to talk about finding the volume of a solid. And there's going to be two methods that we're going to use. There's actually more methods to find the volume, but we'll only discuss two of them in AP Calculus AB. So the first method we're going to use has to do with when you find cross sections of a 3D object. So if you look to the right, there's a pyramid with a square base. The cross section of that pyramid, there's actually two ways to cut it and get a different cross section. But if you cut it the wide way, like you can see there, the cross section of that is a square. Actually, just a side note, if you were to cut it like along the y-axis, the cross section would be a triangle. So I'm hoping you've heard the term cross-section before. If you've taken biology or anatomy, it might have come up at some point. But just know the cross-section is what you get when you cut through an object. So we're going to have two formulas that we're going to use. So for cross-sections that are perpendicular to the x-axis, make sure you read the problems really carefully. The perpendicular to the x-axis ones are going to be our nicer integrals. They're nicer because they are going to be in terms of x. So we're going to be finding the formula for the area of a cross-section. Then we integrate it from the lowest x value, the leftmost x value, to the rightmost x value. I'm going to say x equals a and x equals b in this case. If you have cross sections that are perpendicular to the y-axis, these, by the way, sometimes they're not going to give you the equation in terms of y, and you're going to have to write it. You'll notice we do have a of y there. You are going to be finding the integral of the area with respect to y. Keep in mind that your limits of integration must also be y values. I'm going to write y equals c and y equals d, so your lower y to your upper y. And the a of y and a of x are the formulas that you have. You'll notice I wrote C warm-up. If you didn't print out the paper, you probably have no idea what I'm talking about. If you printed out the paper, just know that we're going to be doing those formulas in class together. So here's my first example. We are going to be finding the volume of a solid whose base is the region bounded by the x-axis, x equals 9, and y equals x squared. And we have square cross-sections that are perpendicular to the x-axis. There's a lot of stuff going on here. The first thing you need to figure out is, are you perpendicular to the x-axis or the y-axis? X-axis, once again, that's the easier one. That's the one where we do it in terms of x. So thankfully, we do have that one in here. The next thing that's important is we have square cross-sections. You do need to figure that out. It's not always going to be squares. It varies. Sometimes it's circles, sometimes it's semicircles, sometimes it's triangles. So it's going to vary based on the problem. So as with when we found the area of between curves, you're probably going to want to make your first step of this to draw a picture. I do have a picture on the side. I'm not sure if you can see what's going on there. You kind of have to use your imagination. But I'll go ahead and I'll draw you a picture and I'll explain what's happening. So first of all, this is the area of my curve between the curve and between the curve y equals square root of x, the line x equals 9, and the x-axis. Now, I am not going to be finding, so the first thing people tend to want to do, and I'll tell you right now this is wrong, is they want to do like this. So if you do this, that is going to give you that's a great integral for that area. That's not what we're trying to find, unfortunately. We want to find the volume. So you'll notice that I said we have square cross sections. In this formula right here, this is the area of a cross section. So the square root of x is not a square. We actually need to use what we've learned from geometry. You probably learned the area of a square before geometry, but some of these are going to be more more challenging, so you'll be happy to have that geometric knowledge. So basically what's happening here is this right here, this shaded yellow area, is the base of my solid. What they're going to do is they're going to take that base and they are going to build up squares out of that base. So I'm going to have, you have to use your imagination here. I'm going to have a bunch of squares just coming up and out of the base. There's going to be just like many, many, many squares. So you have to think of this 3D as like coming out of the screen of your device. It's building upward. I tried to find a picture online with it. I don't know if you can see it from there, but this is like each of these is a square in here. So again, you got to use your imagination. I'll see if I can find one that's a little bit more three-dimensional to show you for this in the class. So basically, though, I do want you to know that I'm going to have like many, an infinite number actually of little squares. Each of these things is the bottom of a square. So each of those black lines that I just drew is the bottom of a square. So what you're going to want to do now is you're going to probably want to draw that cross section. And the cross section is a square. We already established that. The base of this square, so I'm gonna color code it a little bit. This base right here is equivalent to a base right here. So each of these bases there. So the length of this square is actually going to vary. Like over here, it's going to be, that side length is going to be really small, but you can see like here at 9, it's going to be a little bit bigger. So we're not going to write it using a number. We're going to write it using the formula, the square root of x. We also know that since this is a square, all 4 sides are the same. This side is also going to be the square root of x. So the area of this, which is my a of x, is going to be the square root of x squared, which actually is just x. So now what I'm going to do, I have the a of x. That's really the hardest part of this. The next thing I need is I just need to write my integral, and then I'm going to take the integral. So my integral is going to be that x that I just found times dx. The limits of integration are going to be my lowest x value, which is 0, to my highest x value, which is 9. Go ahead, pause the video. I want you to take the integral of this one. So hopefully you got x squared over 2 from 0 to 9. That ends up giving you 81 over 2. And that's the volume of that solid. So the second example it's kind of similar to the first one, but I think it's slightly harder because we do have semicircle cross sections. You're welcome to pause and try it on your own, or you can just let me go through it. So for this one, as with the previous one, the first thing you're going to want to figure out is if you're perpendicular to the y or the x-axis. Thankfully, we're the x-axis again. The next thing is you need to find out the cross sections. So the cross sections here are semicircles. That one's a little bit more challenging, and it is the same equation as before, which is helpful. So I'm going to just kind of draw a very quick sketch of that again. Okay, so we know it's going to look like that. And I did attempt to draw the I found a picture of the solid that's generated. It's really hard to see it even just looking at it like this, but I'm hoping you kind of get the idea of what's happening. So basically what we have is we have this right here is the base of your cross section, which is a semicircle. So you're going to have a bunch of semicircles. You can imagine these are coming out of your device. And it varies depending on where you are. But if you think about all the semicircles kind of coming out of that together, that's what we would have when we have this solid here. So as with the previous one, you're going to want to start by figuring out the area of the curve. That generally is the most challenging thing, so we're going to start by figuring out what is our area. And so we know, again, this is the base of a semicircle. I'm going to use color again, so this, do it in a different color than what we had. This corresponds to that. I think it's helpful to see which side it corresponds to. You're welcome to draw that every time. So we know then that green length right there is equal to the square root of x. So it's going to be equal to that equation right there. Now you just need to figure out what is the area of that semicircle. So we know area equals pi r squared. So the radius is 1/2 of the square root of x. So it's going to be this. And my final answer for, oh, sorry, I made a mistake on this. I just realized. I'm hoping you noticed. That's the area of a circle. This is a semicircle, so it's going to be half of that. So I need to do times 1/2. When I multiply that out, I get 1/2 times pi times x squared, or sorry, just x over 4, which gives me pi x over 8. So now I'm going to write my integral. It's still going to go from 0 to 9. We're looking at our x values. I have pi x over 8 dx. Definitely pull the pi over 8 out front of that integral, otherwise it's really complicated to work with. And you do get a more complicated answer than you did previously, but keep the pi as it is. You can assume that when you get a question like this, you're just going to need to keep the pi where it is. Your final answer is going to end up being 81 pi over 16. So this next problem is a little bit more complicated. We have a base of a solid that is the region bounded by the lines f of x equals 1 minus x over 2 and g of x equals negative 1 plus x over 2. I'm actually going to add in also the y-axis and the line x equals 2. Rectangles of height 4 minus x are perpendicular to the x-axis. So we're going to find the volume. First thing that I want you to notice is that we're perpendicular to the x-axis, so we're still using that a of x formula. The second thing is your cross-sections. So they don't say cross-section, but that's what it's implied. This is my cross-section right here. And they tell us it's rectangles of height 4 minus x. That's a little bit weird, so let's talk about that in just a second. First thing we're going to do, though, is draw a graph. And I like to rewrite my equations that are given like this. I like to write them in slope-intercept form. So f of x is equal to negative 1/2 x plus 1. And then g of x is equal to 1/2 x minus 1. Go ahead, pause the video. I want you to draw them on your own. So hopefully you got something that looks like this. I just kind of zoomed in on the part of the graph that I actually need to worry about, but if your graph is bigger, that's fine. So the base of our solid is going to be this shaded area right here. I think a lot of people get thrown off by that 4 minus x. We don't need that yet. The first thing that you're going to worry about is draw the base of the solid, which is the region that they gave us. So we have that now. Now we need to worry about the rectangles of height 4 minus x part of this one. So basically what that's saying is I have a rectangle and it's going to look like this. What they're actually saying is depending on what your x value is, depends on the height that you have. So like the rectangle that I have there drawn in yellow is going to have a bigger height than the rectangle right here. That one's going to be a little bit smaller, so it's going to vary, which is fine. The base is also going to be different. So let's start with the base of the rectangle. So the base of the rectangle, I'm going to draw that right here. I always like to draw it in a special color. base of the rectangle is going to be the two equations that I have, those lines. It's going to be the f of x minus g of x. You will want to simplify those two out, and when you do, you get something actually pretty nice. It's going to be 2 minus x. Then the other part of the rectangle is these sides I have right here. So they told me that the rectangles have height 4 minus x. That's this part right here, which also corresponds to this right here. So I now have a rectangle. I have the base of the rectangle. I have the height. I can find the area. And that's going to be my a of x. So my area of a rectangle is base times height. And that gives me x squared minus 6x plus 8. So we have our area. We know where our x values start and end. So now we can write our integral. So my integral is going to go from 0 to 2. And it's going to be the integral of the area function I just found in terms of x, thankfully. We'll do a y one in just a minute, though. Go ahead, pause the video. I want you to do this on your own, please. So hopefully you got x to the third over 3 minus 3x squared plus 8x. And when you evaluate that, you should get 20 over 3. So this is our last problem for the video. We have a region bounded by y equals x squared and y equals 9. So far it looks not bad, but then we see we have bases of square-shaped cross-sections that are perpendicular to the y-axis. We're going to find the volume. If you have something that is perpendicular to the y-axis, you must integrate with respect to y. So there's no way around it. You have to do it. Unfortunately, your nice equation of y equals x squared is going to change. It's now going to be in terms of y. So let's do this together. First thing that you're going to want to do, I always say draw a picture. That's going to help. So this is the graph of y equals x squared. Then I'm gonna show the shaded area. We'll just do it in yellow this time. So far it's not that bad. The problem is going to come when we have to deal with the fact that we need to write our equation in terms of y. So I know right now that my equation is going to be, it's going to start at my lowest y value, which is 0, to my highest y value, which is 9. And then I do need an area equation with respect to y. So that's the first thing I need to have. That means all of the variables in the equation will be y's, not x's. So I have y equals x squared. In order to find the equation with respect to y, I need to solve for x. When I do that, I get x equals plus or minus the square root of y. Do not forget that plus or minus. So the plus part is this, the minus part is this. We need to include both of those when we're writing an equation of it. But actually, I'll show you what we're going to do next. It's a little weird. So what we have cross sections that are perpendicular to the y-axis. They are in the shape of squares. So at least it's squares. That's something that's helpful. So they look like this. We're perpendicular to the y-axis. This is the base of my square, and it's going to kind of come out of the page like this. Again, you're going to have to use your imagination a little bit. But it's going to vary. Your size of the square is going to vary based on what your y value is. So let's go ahead and we'll draw the squares. Bottom of my square I'll do in blue this time. And so this blue part is, you're going to kind of have to figure out what is the distance between the two halves of the blue part. So the distance between the two halves for the first part of it, like this part over here, the distance is going to be the square root of y. For the second part of it, the distance is going to be the negative square root of y. Be careful. If you add those and get 0, you're not going to get the right answer. You can actually think about it as like this is going to be the square root of y, my rightmost value, minus the negative square root of y. So actually this side length will be 2 radical y. I think getting that is the hardest thing about this problem. Once you get that though, it's not that bad. So it's a square, so I have a side of 2 square root of y. I have my other side of 2 square root of y. My area is therefore going to be, my a of y is going to be 2 radical y squared. That gives me 4y. So at least something good happened. I now have a nice equation, and it's not that hard to take the integral of, thankfully. So I'm going to integrate 4y times dy from 0 to 9. Go ahead, pause, do it on your own, please. So I usually like to pull the 4 out front, by the way. And I get y dy, which gives me 4 times y squared over 2 from 0 to 9. You can either pull the 4 out front until the very end, or you can just rewrite it as 2y squared right now. Either way, you get 2 times 81, which ends up giving you 162.